178. Page 178 in your textbooks. You did page 178 to 179, numbers 14 through 28, the even, and working with adding polynomials together. And on page 181, you also did 8 through 20, the even, as you worked on subtracting polynomials. Of course, we know that we never really subtract in algebra, but rather we would add the inverse. And when I say polynomial, that simply refers to some algebraic expression that consists of at least, for this class, 2 terms. Poly meaning many, so for this class, again, 2 or more terms will mean polynomial. But specifically, if I had just 2 terms, we would ordinarily refer to that specifically as a binomial, 3 terms as a trinomial. We don't have special names for more, we just generally refer to those things as polynomials. But just a single term, to contrast with the polynomial, a single term we would refer to as a monomial. As we talk about the order of a particular term, you would simply do what? Yeah, you'd add the exponents of all the various variables in that term together. For a polynomial's degree, what would you do? Remember, you can pause the video when I ask questions, think of your answer, and then press play again. But to find the degree of a polynomial, you would simply find whichever term in that polynomial has the highest degree. If we were to put the highest degree term first, and the next highest degree term second, then the next highest degree, and so forth, we would be arranging that polynomial in what kind of order? Yeah, descending order is the order we would be looking for there. That's something that we looked at here in pages 178 to 179. You did the evens. Let's start with number 14. Notice that both polynomials, both binomials specifically, were in descending order. X to the first, then x to the 0, or x gone. Remember that anything to the 0 power is 1. So when we see 3x minus 5, that's the same as 3x to the first minus 5x to the 0. We have a single x, we have 0 x's. You could say 5 times 1, it's still 5, right? So anyway, you add those polynomials, your answer should have been 11x negative 3. Number 16, again, notice each of those trinomials is in descending order. When you add them together, you should have gotten 6p squared negative 13p negative 1. For number 18, notice this time you're adding a trinomial and a binomial. Well, remember, only add the like terms. The 4y squared has no friends, so it just stays 4y squared. The 2y, 3y give you 5y, the negative 9, positive 8 give you negative 1. Number 20, you add the x, well, there's no friends for the x cubed, so there's just 5x cubed. No friends for the 3x squared, so positive 3x squared. Then the 8x and the negative 2x, they have friends, positive 6x, and the positive 2, positive 1 gives you positive 3. Again, we want to combine our terms and then arrange them in that descending order. So is it entirely wrong to say 5x cubed, positive 6x, positive 3x squared, positive 3? Not entirely wrong, but again, with where we're going with this in the coming days, you're going to want descending order. The cube, then the square, then the understood first power, then the x being gone, or the x to the 0 power. As we look at number 22, here you had to find your like terms, and it would help to arrange them in vertical terms there. Now, again, if I'm just marking them in the textbook, I'll just underline certain ones, circle others, squiggle, underline others. But if I'm going to have to copy it on the board anyway, I'm going to copy it down so that they're nicely, neatly lined up. And so far, nope, they just broke order on me. There we go, almost got that one wrong there. Notice, by the way, a negative 2ax, positive 2ax, cancel those. That makes your ax column very easy to add. Don't forget, this is a positive 1, this is an understood 1 as well. Combined to get a negative 10, positive 1 with that gives negative 9a. And then over here, they're all positives, just add them all up, keep the sign. We get the positive 10x, and this should have been our answer here. Although, if you're wanting the descending order, we could perhaps put the positive 8ax first, followed by the others. Here again, there's not necessarily a single power. Like here, the x itself is descending. Here, there's matching powers of a, matching powers of x. This is technically your highest term. We could have perhaps listed that first. Not as big a deal there. Number 24, again, we could copy down all of our x's, our y's, our z's into columns. Again, nothing wrong with marking them with different methods, but again, if I've got to put it on the board anyway, I'm going to go ahead and put it in columns as I do. And all right, by the way, resist the urge here to cancel your negative 10y's. They don't cancel. Positive and negative 2ax cancel. A positive 10y, negative 10y would have canceled. These do not. Similarly, the positive 5x, they do not cancel. Notice I've got 3 positives here to get a total of 17. Put the positive 17x with the negative 11x to get positive 6x. Here, put your negative 10s together to get negative 20, positive 3, that gives negative 17y. Here, put your 3 negatives together to get negative 19z, positive 4z with that gives a negative 15z. And there's our answer for number 24. Number 26, we had to distribute before we could do anything else. So we've got a 2x, negative 7, or 7.0, I just assume leave 7, positive 6, or 6.0, negative 4x squared. Here there is a single variable, so I particularly am interested in descending order when there's a single variable. I'm going to put the negative 4x squared first, then the positive 2x, combine the only like terms I had to get negative 1, and there's our answer for number 26. Number 28, again, we're going to distribute to get a 5x squared, positive 5x, negative 25. Distribute to get a 6x squared, negative 4x, negative 14. Now we combine the like terms. The 5x squared, the 6x squared gives 11x squared. The 5x, negative 4x gives us the positive x. Negative 25, negative 14, negative 39. And our answer for number 28, the last of the homework problems from that section. If you have any questions on that homework, be sure to send me an email and I'll address those concerns with you. Turn over though to page 181 now. Now let's take a look at the subtraction. Again, we don't really subtract, we would add the inverse. So remember, it's the second thing. It's the thing after the subtraction sign that has to be changed to the inverse. And everything after the subtraction sign that's in those parentheses has to be changed. Kind of, in a sense, you could say we're removing parentheses preceded by a negative. So number 8, we've got the 8x squared, the positive 7x, the positive 9, and we're being told to subtract a 5x squared, positive 3x, positive 5. But again, we don't subtract, we add the inverse. So I'm going to change my subtraction to addition, and every one of these signs has to change. Well, this is an understood positive. It has to change. Negative, negative, negative. Now I can add them together to get 3x squared, positive 4x, positive 4. Number 10, we've got a 7a positive 4. We add the inverse, negative 2a, positive 3, if you're wanting to do it side by side, to get a 5a positive 7 when you combine your like terms. Number 12, very similar. It's a 4x minus 9x, negative 2x, positive 8, to get 2x, negative 1. Number 14, you've got the binomial and the trinomial. Again, all the signs in that trinomial have got to change to become a negative 2n squared, positive 8n, positive 7. Be careful, the 4n squared and negative 2n squared combine to give you 2n squared, but your positive 8n has no friends. Put that second to keep your descending order. And then the positive 1, positive 7 give positive 8. So your answer, 2n squared, positive 8n, positive 8. Number 16, again, the terms are nice, neatly lined up, but you have to add the inverse to get 11x squared, positive 2x, negative 6. Number 18, the 3x to the 4th does have a friend in a positive 2x to the 4th once you've changed the sign. That's 5x to the 4th. Your negative 2x cubed, once you've changed the sign, has no friends. It just stays negative 2x cubed. Your negative 7x squared has no friends. It just stays negative 7x squared. And then your positive 8, positive 3, once you've changed the signs, combine to give you a positive 11. Again, note the descending order. Now, it's incomplete descending order. You've got 5x to the 4th, negative 2x cubed, negative 7x squared, positive 11. So there isn't an x to the 1st power. There's a gap in the descension, if you will, but still the descending order. And number 20, again, changing the signs of that binomial at the end, combining your terms, your answer should have been 4x cubed, negative 4x squared, negative 3x, positive 7. If you have any questions at all on the homework, please send me an email. I'll get with you and make sure we're good to go on those. For now, I want to take a look at a word problem on the screen. And take a moment, read it there at your seat. I'll read it aloud after I get the board erased. It says, James and Catherine together have $1,900 in a savings bank. James has $300 more than 3 times the amount that Catherine does. How much does each have? Presumably, we have here siblings. James and Kat, we'll call her, because that's easier than writing out Catherine. And James has a lot more than Catherine has. Presumably, let's say he's the older brother, and maybe he's been working for a little bit, so he's got a lot of money. Catherine just has a little bit of money in savings. And the question is, how much does each have? Well, obviously here, how many unknowns? And they are I trust you had 2 unknowns, James and Catherine. At your seat, pick one to be x, then represent the other in terms of x. Pause the video. Right, Catherine needs to be x because it comes back to Catherine. James has 3 or more than 3 times the amount that Catherine has. Since it comes down to Catherine at the end, she'll be x. And how did you represent James? Good, I trust you had 3x plus 300. $300 more than 3 times the amount Catherine has. Set up your equation and solve. Pause the video. I trust you had this equation. 4x plus 300 equals 1900. You're adding these 2 amounts together because it says together they have $1,900 in the savings bank. You would subtract the 300 from both sides to get 4x is equal to 1600. By the way, I don't mind if you do that step in your head now. We were showing that step for a while. Now, I will say some of you, and you know who you are, struggled with knocking this out and putting a plus 300. If you have had that problem, then for a few more weeks, you need to keep putting negative 300 on both sides to make sure that you get in the habit of changing the sign. Or at least put the negative 300 on that side. Anyway, we end up with x is equal to 400, which means who has $400? Yeah, Catherine has $400. And James then would have 3 times that amount plus 300 more, which would give him $1,500. And these should be our answer to today's word problem. Just a quick refresher, want to make sure we remembered our process for solving word problems. How many unknowns? 2. What are they? James and Catherine. Who gets to be x? Catherine, because that's who it comes back to in the end. How do we represent the other unknown? 3x plus 300. Set up your equation. Solve and get your answers. And since it said how much does each have, both of these are our answers. And I just realized the equation didn't make it on the screen. Wrote too far over toward the middle of the chalkboard. But there's the equation that we should have had that I was pointing to a moment ago, so you could tell what I was doing. All right, turn to page 185. Page 185. I want you to do the review 9 through 14 at the bottom of the page. Page 185, the review 9 through 14. We do have a quiz coming up here in just a few minutes. This is going to be our last shot at reviewing over the things that we talked about in yesterday's lesson. So as we go over this, do your best. Go ahead and pause the video. When you finish with the assignment, go ahead and resume the video. All right, let's go ahead and take a look at how you did on the review, numbers 9 through 14. Again, a lot of terminology that you need to be ready for on this quiz. Single term we call A, monomial 2 terms we call A, binomial 3 terms we call A, trinomial. By the way, what separate individual terms? How do I know how many terms are present? Yeah, the addition, subtraction signs, unless they're grouped, for instance, right? So a 3x plus 2y is 2 terms. but 3x plus 2y is all one term because the plus sign is within a grouping, or even 3x plus 2y over z. This is all one term because it's grouped again. But the numerator is a binomial, the whole expression, a monomial. Okay, so just again, some review back to the earlier part of the year. Again, when I take terms like 3x, negative 5x squared, positive 1, negative 3x to the fourth, if I wanted to put those in descending order, what would it look like? Pause the video. Yeah, I should have had the negative 3x to the fourth first, then the negative 5x squared, then the positive 3x, finally the positive 1. Remember, the sign is part of the term, so there's your highest power, then your next highest, then your next highest with an understood positive, and finally your lowest power term. Okay, so the descending order, remember, is where they get smaller. They did a good job, though, setting up for you, for the most part, these terms in descending order already. So on number 9, just adding them together. You go to positive 1x cubed, positive 1x squared. The negative x, positive x cancel, negative 1. So positive x cubed, positive x squared, negative 1. Number 10. Again, only combining like terms. 5x cubed has no friends, so just leave the 5x cubed, then a positive 2x squared, negative 9x, positive 2 for your answer. Number 11, before you can do any addition, you have to change the signs. Okay? We're adding the inverse here. So we end up with a positive 6a squared, positive 2a, negative 16. Number 12, we'll keep the positive 4x to the fourth. We'll keep the negative 3x cubed. We'll combine the x squares to get positive 6x squared. We'll combine the x's to get negative 6x. Your answer one more time, 4x to the fourth, negative 3x cubed, positive 6x squared, negative 6x. Number 13. Something interesting I want to point out here on number 13. Did you notice that every single term is third degree? Every term is of the third degree. You have an x cubed. You have an x squared, y to the first. That's a degree of 3. You have x to the first, y squared. That's degree 3. You have y cubed. That's degree 3. But I want you to notice what's happening. X is descending. Cubed, squared, first, gone. Notice the y, gone, first, squared, cubed. This is what we call descending ascending order, where the first letter alphabetically will descend, the second letter alphabetically will ascend. You're going to see a lot of that in the coming days. So again, just kind of pointing this out early before you need to do anything with it. That said, again, you're just focused on combining like terms once you've added the inverse. Number 13, your answer should have been a 1x cubed, positive 8x squared y, negative 12xy squared, negative 3y cubed. And then for number 14, we've got to keep the signs of the first polynomial, keep the signs of the second polynomial, change the signs of the final polynomial. When you combine the like terms together, your answer, 17x to the fourth, negative 1x cubed, positive 1x, positive 6. Again, if you have any questions, be sure to email me before you get ready to take this quiz. You can finish the YouTube video later. Find it in your YouTube history, resume where you left off. But if you have any questions on this, make sure you reach out to me, and I can get back with you and try to help you out. If you're good to go, then you need to right now, don't pause the video just yet, right now you need to ask your parents for quiz 7 from your, quiz 8 from your packet. Ask your parents for quiz 8. Put everything else away, just have out a blank sheet of paper. We're going to go over the quiz together on the video and then go from there. So take a moment, pause the video if you need to ask your parents for quiz 8. Once you've got it, resume the video for just a moment. All right, once you've got your quiz copy from your parents, you've got a blank sheet of paper, everything else is away. Do have out a pencil, of course. First and last name at the top of your paper, along with today's date, which is 9/29/20. 9/29/20. Let's take a look at the quiz together very quickly before I have you begin working. Numbers 1 through 3, you're going to tell me, is that a binomial, a trinomial, or a monomial? Notice polynomial is not an option. Technically, it could apply to all of them, and to some people, not necessarily to me. Number 4 and number 5, you're going to rearrange each of those polynomials in descending order. For number 6 through 9, just add or subtract depending on what's indicated to you. And then on number 10, you're going to solve the word problem following the process that I went through in class. I want to see how you set up your variables. I want to see your equation, and I want to see your answers to receive full credit. Don't just write the answers. At this time, pause the video. We'll come back with a new topic once you're finished with your quiz. Be sure to have your parents email me the quiz. All right. Well, I trust you did well on your quiz that you took just a moment ago. For now, want to begin looking at a new topic for you in your textbook, or in your notes, and that's multiplying monomials. Multiplying monomials. The next section in your notes. As we look at multiplying monomials, I want to go back to something you should have learned in pre-algebra. I'm going to address it, though, as if you haven't learned it, but at the same time, I understand you probably have. If you took an a squared and you multiplied it by an a cubed, well, remember, a squared simply means a times a. And remember, a cubed simply means a times a times a. So if you're multiplying a times a times a times a times a, you essentially have now 5 a's being multiplied. So therefore, you would get a to the 5th. If you were to take x and multiply it by x squared, you're essentially taking an x and multiplying it by x times x. Well, x times x times x, that's x cubed, isn't it? Notice what we essentially are doing here. It's as if we're taking the exponents and doing what to get our answer? We're adding them, right? We're just adding the exponents to get our product, if we were working with just x's. But imagine for a moment I had an x squared times a y cubed. This means x times y times y times y. I do not have 5 of anything. I still have only 2 x's. I still have only 3 y's. So if I multiply x squared times y cubed, I get x squared y cubed, right? Because the bases don't match, I don't have 5 of anything. I do not add the exponents. So I want you to write this statement in your notes and put a star next to it. You're going to memorize this statement so that you could say it in your sleep. To multiply like bases, add the exponents. To multiply like bases, add the exponents. To multiply like bases, add the exponents. If you were in my class, I would have you say after me, to multiply like bases, what do we do, class? And you would say, hopefully you just said add the exponents. You need the practice of saying it out loud. It helps it stick in your brain better. So if we want to multiply like bases, class, we add the exponents. However, with monomials don't just consist of letters, right? A monomial could be like a 3a squared, right? A monomial could be like a 5a cubed, right? And so when you multiply the monomials, you understand there's more to multiply than just the letters or the variables or the literal coefficients. So there's 3 steps then to multiplying monomials. Step number 1, sign. Step number 1 is to take care of the sign. Keep in mind, if the signs are the same, you get a positive. And if the signs are different, you get a negative. So as we multiply monomials together, same signs positive, opposite signs or different signs negative. In this case, notice we have the same signs. They're both understood positives. So our answer would come out to a positive. The next thing we'll take care of, number 2, is the numbers. Sign numbers. We're going to multiply the numbers together. 3 times 5 equals, hey, not bad for first thing on a Tuesday morning, 15. All right, pretty easy. And the third step is to take care of the last thing, and that's the letters. And remember, to multiply like bases, you add the exponents. If you didn't say that just now, I want you to write it down again. To multiply like bases, add the exponents. Notice the abbreviation, because I am lazy. I don't want to write the whole word. To multiply like bases, add the exponents. And again, you should have a star next to that earlier in your notes. Doesn't hurt to start again. So a squared, a cubed, that we put them together for a total of how many a's? A to the fifth. How about this one? Write this one down. Suppose we had a negative 3a squared b times a 5a cubed b squared. I have 3 steps to multiplying monomials. Say them with me. Sign, number, letters. I'm going to take the S off because it takes too long to say the word and I'm that lazy. Yes. Sign, number, letter is how I say them. My 3 steps to multiplying. Say them with me. Sign, number, letter. Again, sign, number, letter. If you'll remember those 3 steps, you won't make little mistakes of oversight and carelessness. Sign, number, letter. Sign should be, well, they're different. So if they're different, my sign class should be, the number is still just 3 times 5, so again, still. When I multiply the a's, it's still a squared times a cubed, so we still add the exponents to get a to the. And then when I multiply b times b squared, here's where it's important to remember, this is not an exponent of 0. There's an exponent of understood 1. So when I add the exponents, I should get b, good, cubed, or to the third, but cubed is the better way to say it, because fewer syllables, and we're lazy. So negative 15, a to the fifth, b cubed. Write this one down. Negative 4xy cubed times negative 2x squared yz. I have 3 steps to multiplying these 2 monomials together. My 3 steps are, let's say it with me, sign, number, letter. As I look at the sign, I notice once again they are the same. And if the signs are the same, I get a. When I multiply the numbers together, I get. This is an understood x to the first. And when I multiply like bases, I add the exponents. So here I'm going to get x cubed. Here I've got a y cubed. Here I've got a y to the first. When I multiply these like bases, I'm going to add the exponents to get y to the. And then there's this z that's all by its lonely. Has no friends, but it still exists. Don't forget the z. There's no other z's to combine it with and multiply it by, but it's still being multiplied. Just bring it down. One quick word. What if I had something like a 2a times a negative 5a times an a cubed times a negative 4a squared times a 3b? Well, when you have multiple factors, remember, there's another rule you could use. Okay, so the next rule you could use, remember, is if you have an even number of negatives, you get a positive. And the odd number of negatives gives you a negative. How many negatives do we see in this multiplication problem that involves multiple factors? You have 2 negatives. Is that even or odd? It is even, so my answer will be positive. However, had this been a negative 2a right here, or better, yeah, just to show this, you could just have a negative a cubed, meaning negative 1a cubed. Well, now I'd have 3 negatives. So if I had 3 negatives, the answer comes out positive because I now have an odd number of negatives, right? But as far as the steps, you're still multiplying monomials. You still do sign, number, letter. So the sign we just took care of. We now, where we ended up, had 3 negatives. Odd, negative answer. Number, 2 times 5 times 4 times 3. Good, 120. Right, easy way to do it is think of 10 and 12. 10 times 12 gives me 120. And now for my letters. To multiply like bases, class, we add the exponents. And most of the bases are like. I will add the exponents to get a to the, good, 7th power. Remember, we have understood ones here. And then there's that b. B has no friends, but he is still being multiplied. He doesn't just disappear. Keep the B. Questions on multiplying, well, I say that out of habit. If you have questions, be sure to email those questions to me and let me know. I'll work with you. For now, I want you to do page 185 at the top of the page. Numbers 1, 3, 5, and 7. Page 185 at the top of the page, numbers 1, 3, 5, and 7. You may pause the video. All right, let's see how you did on page 185. Numbers 1, 3, 5, and 7. If you're not finished, then you should have paused the video, so do that now. Number 1, sign, positive. Understood, by the way, and you could leave it understood. I normally will because I'm normally lazy. Number, well, 2 times 4 is 8. And letters, we add the exponents, x cubed. Number 3, sign, understood, positive again. Number 10, letter, x to the 4th when we add the exponents. Number 5, sign is once again understood, positive. The number is 4. My x's come out x cubed, and the y's come out y to the 4th. You multiply the x squared and x together, you multiply the y and y cubed together. On number 7, once again the signs are the same because they're both negative. So once again I get a positive, which I could leave understood. 3 times 5 with the number gives me 15. Sign, number, letters. A squared, a cubed. We've seen that one before, a to the 5th. B cubed, b to the 5th, b to the 8th. Again, you are adding the exponents. If you did not get these correct and you're confused on how to multiply monomials, again, send me an email. I'll reach out to you and give you the help that you need. That's all for today. Let me go and give you your homework assignment, and you'll practice with some of this more this evening. Your homework for tonight is to do page 185, the practice, 2 through 8, the even. We just did 1 through 7 odd. You're doing 2 through 8 even. That's the practice section at the top of page 185. Page 181, at the bottom of the page, review 11 through 14. Page 181, at the bottom of the page, review 11 through 14. And page 91, I've got 2 word problems for you. Page 91, numbers 51 and 53. Page 91, word problems 51 and 53. Again, if you have any questions, be sure to email me. Otherwise,